Hey, welcome back to RamZland. Today I want to show you the reaction between potassium and water. Check this out. All I'm using in this investigation are two 250 milliliter graduated cylinders that are filled with just 100 milliliters of distilled water. I'm using elemental potassium that's stored in mineral oil because it reacts with water and moisture in the air. I'm using phenolphthalein as an indicator. Remember, potassium is an alkali metal that has 19 protons and was discovered in 1807 by the electrochemist Sir Humphrey Davy through the electrolysis of molten potassium hydroxide. To begin, I'm going to add a few drops of the indicator phenolphthalein to one of my graduated cylinders. You'll notice that phenolphthalein is clear in the presence of water or anything that's acidic. Next, I'm going to use my spatula to cut a small chunk of potassium from this block. You might be surprised how easy it is to cut potassium. It's almost as easy as butter. And when I cut it, you can see how bright that luster is before it develops an oxidation layer and then turns kind of a dull gray rather quickly. So I'm going to use this small little piece that we cut right here. Okay, now we're ready to add this little piece of potassium to our water. This is a single displacement reaction that creates potassium hydroxide that's very alkaline. That should change our phenolphthalein to a bright pink color in the presence of a base. It'll displace hydrogen gas. Here we go. Watch, look at that. Isn't that amazing? So right here, I've got some potassium hydroxide, that's part of our product, and this white gas that's being displaced, that's hydrogen. So when I add my solution of phenolphthalein, it should change color in the presence of a base. Here we go. Look at that. Isn't that cool? You can see it's more pink up here where I have more potassium hydroxide and a little more clear down here because it hasn't diffused all the way through the graduated cylinder. Just awesome. Here's the balanced equation for this amazing single displacement reaction. We start with the reactants potassium and water. We have 2 moles of potassium, that's the 2K, and 2 moles of water, that's the 2H20. When those come together, they create the products potassium hydroxide and hydrogen gas. We have 2 moles of potassium hydroxide, that's the 2KOH, and the diatomic molecule hydrogen gas, that's the H2. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.